Okay, yep, that's what I'm going to do. So the original title was what to do following this dry weather. And a lot of you still kind of dry weather, but hopefully you'll get some rain or snow, and maybe it'll stick to the field instead of blowing away, and then you'll be in good shape for this coming spring. So let's just all assume that that's right. One of the things that you've heard of, or maybe you've experienced yourself, is you know that when you had soil samples done, your neighbors did or something, that the nitrate values have been coming back very high. So whatever moisture we had last year was through the end of the season, and usually it's kind of backwards. What it usually is, we usually get mineralization on the front end and not so much at the back end, and we didn't get anything in the front end, and we got a little bit in the back end. And so a lot of people, part of it's because residual nitrate after corn, for example, since the corn crop was pretty lousy, the nitrate is still there, so that's kind of easy to explain. But we had reasonable wheat crop, and actually the nitrate after the wheat was higher than what people expected, and that was a little bit of a surprise. So anyway, that's what's happened, and I think because of that, because of the long fall, we had a lot more soil sampling, a lot more soil testing last year than we did. So we did in the past. So that's a very good thing. So then with these higher values, do you really believe them, or what? So the thing is, if you zone sample and you get high values within the field, within those zones, then I would absolutely believe it. If you have a high value with a composite test in the field, then I would be less confident that that's really what's going on. So all it takes is a few soil cores from an area that has some higher nitrate, and it just skews everything. So that's another incentive in the future to do some zone sampling. Whether or not we have any time at all this spring for doing that kind of sampling or not remains to be seen. But if you want to explore some fields and you have the time and you have the people to do that, that would be a really good exercise, and it'd help you try to figure out what to do for this coming season. So we use our nitrate value to develop our recommendations. It's part of it. We have a big deep freeze. It's our great advantage over the rest of the corn belt, wheat belt, any belt, is that it's in the freezer right now. You know, the beets are in the freezer, the nitrate's in the freezer, everything's in the freezer. And so the nitrate that was there in the fall is going to be there in the spring, and so you can take advantage of it against and they're woven into the fertilizer recommendations, especially in our nitrogen calculators. The thing is that the response, the yield increase and quality and all of that is not linear. The old formulas made you believe it was, but it's really not. And so what happens is the first small amounts of nitrogen you apply, you get your greatest return with it. And as the amount of nitrogen that you apply goes higher and higher, then each incremental amount of nitrogen you get a lower return for it, to the point where it costs you more to put on that nitrogen than you're going to get back with the crop. So that's the question. Do you shoot with that maximum yield? You spend $20 to get 10. You know, it doesn't make a whole lot of sense. You're going to need a bigger wheelbarrow. So we have the nitrogen calculators for wheat, and I'm just going to talk about the ones for wheat because this is a wheat and soybean meeting here. So what we do is we have the state divided into those three regions, and the ones that you should be interested in is the eastern North Dakota and then the Langdon region. And the Langdon region is partitioned out because that area, when you dig around in it, when you take a soil sample on it, it has these little gray, flat, rocky things in it. So that's shale from the underlying bedrock, because that area is pretty shallow to shale, and so the glacier left that behind. So why is that important? It's important because that shale has high amounts of mineralizable ammonia in them, 65 million year old at least, non-exchangeable ammonia that's being released, and so that soil acts like a slow release fertilizer, and so that area needs less nitrogen, and so it's carved out and it has a different recommendation system. Our research trials in wheat show that that's absolutely the case. It just needs less in that area. That's why that's different. So when you use the calculator, you choose what your productivity level is. It's the only recommendation we have. And the reason for that is not because the shape of the response curves is really any different from a low productivity to high, but it's just purely economics. If you're in the very southwest part of the state and happen to farm in Bowman, you're really happy to get 30 bushel wheat. I know that's kind of crazy, you know, to this audience, but that is absolutely true. I've talked down there and they say, yeah, that's right. You know, if we get 30 bushel wheat crop, we're just ecstatic. So there's areas in the state that really just have low yield potential, and so you can't recommend 200 pounds of N when you're going to only get 30 bushel wheat. That's just insane. So that's why we have those different levels. So in this area, you're either high productivity, which is, you know, up to 100, from 60 to 100, or you have that 40 to 60, I think that is, in the medium productivity area, and the recommendations are based on that. And it's purely economic, not nitrogen response necessarily. So then you go down, and this is an economic industrial production function. It's a marginal return, if you remember your economics from wherever you went to school. So that means that as you increase the N rate, of course, you increase the cost. So the cost is figured into the recommendation, as well as the yield gain you get from it adding the nitrogen, and also the protein gain up to a point, up to like 15%, and there isn't any. And then it also considers the DOC less than 14%. And I think my penalty for the DOC is twice as much as what it is for the premium. And both are pretty modest, because we don't see those kind of things anymore, but you have to make some kind of a judgment. So I do. But the thing about, so you put in the wheat price that you expect to get, and then the nitrogen cost, either the stuff you bought or the stuff you intend to buy, make some kind of an estimate about what that's going to be. So that's a little bit of a rub this year. So when I put all these together, I never dreamed the nitrogen would ever go more than $1 a pound. And I think urea 28% for sure is like $1.20, $1.30, something like that. Ammonia is almost $1 a pound. And so there's values of nitrogen that are higher than what the nitrogen calculator allows you to figure. And it's not so much, well, it's not the case so far with the wheat, and it's not so far the case with the corn. But if you're sunflower grower, you can contract confections at 40 cents. And I never dreamed that sunflowers ever sell for 40 cents. I just figured 30 cents would be, you know, as much as anybody would ever dream that they would get from sunflowers. And so it only goes up 30 cents. So is the calculator garbage? And of course, it's not. So in some corn belt states, they don't use the actual prices. They use a ratio of what the corn price is versus the nitrogen. And so you can use the same idea here. So if you have nitrogen prices that are above what's on the calculator, divide both the price of the crop and the price of the nitrogen by 2. And so if you have, say, a wheat price of $7 and a nitrogen price of $1.20, then you go to the calculator and you use 3.5 for the wheat, and you use 60 cents for the nitrogen, and you get the same value. So it's almost like magic, but not quite. It's, you know, arithmetic. So in the meantime, I'm laboring over massive Excel sheets, and at some point I'll get nitrogen costs, God forbid, up to $2 a pound, and crop prices that are higher than this. But in the meantime, you can easily work all these calculators. If the nitrogen price is higher, just divide both of them, both the crop and the nitrogen cost, by 2, and you're good. Same value. Okay? So the idea with this is to give you the greatest profit possible, regardless of what you're going to get for the crop or what you're going to pay for the nitrogen, and it works pretty well. So tillage practices, previous crop, it's all figured into that. Click, 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 click. You go down to the bottom, you get a number, and then there's something that just surprises people, because you think these recommendations are chiseled on a temple wall, but they're really not. And so, especially in wheat, You have high protein varieties, you have varieties that struggle to get protein. And then, you know, I've got well over 100 sites that go into this recommendation system, but I probably haven't been to every field that you have, even if I've worked on a few of your fields, I haven't worked on all of them. And so there's things about your field I don't know, there's things about your operation I don't know. And so you get the final number, but the final number is not the final number. The final number is plus or minus 30 pounds of N. Because if you have that low protein variety, you want to kind of move it up a little bit. You know, you want to increase the nitrogen rate a little bit to make sure you don't get that big dock at the end of the year. And if you have a high protein variety and things are a little tight, then maybe shaving it off a little bit. So what I'm really doing here, when I give you the number plus or minus, is I'm giving you credit for common sense. And part of my salary comes from the federal government, so I hope you appreciate that. Because you don't see that very often. All right. So one of the things that makes this work, and the calculator doesn't ask you what your yield's going to be. It has those productivity areas, but it doesn't try to pigeonhole you into what do you think your yield's going to be, because frankly it doesn't matter. It doesn't matter what your yield's going to be. Because the nitrogen rate is related to relative yield. It's not related to actual yield. If you have a low productivity year, it takes more nitrogen per bushel than it would in a normal year to make that crop. And if you have a really good, tremendous year, perfect rainfall, perfect temperatures, not a lot of stress, then it takes far less nitrogen to make a bushel than it would in a normal year. And so it really doesn't make any difference at all. So here on this chart in the northwest corner, this is the western North Dakota. Anybody here from Beach? Nobody, I'm just shocked. So nobody from Beach, but anyway, those are the western North Dakota conventional till wheat sites. And that's the raw yield. And the R squared is a little value there on the bottom there. And 0 means there's no relationship between those dots in that curve at all. And if it had 1, which is impossible in biology, but if it was 1, all those dots would be perfectly on that curve. And so this is 0.16, which is pretty horrible. Significant statistically, but it's pretty horrible. But if you take those values and you standardize them within a plot, within a plot, if your high yield is, I don't know, 60 bushels, something like that, you divide everything by 60, so everything is between 0 and 1. And the next one, maybe the high value is 30, divided by 30, everything's between 0 and 1. So you put it on the same scale, you put everything on a relative yield, and the R squared triples, it more than triples. Because the actual yield doesn't mean anything. It's the relative yield that means everything. And this is a no-till. The R squared there is, I can hardly read it, it's 0.19, I think it is. And that's the actual yield, but if you put it in relative yield term, more than triples up at 0.62. So again, the real yield doesn't matter, it's the relative yield that matters. And so you're scratching your head thinking, this is weird, but that old formula that said you just had to worry about the yield goal and then times some silly number, it made you ignore everything that was going on in the soil. You know, a lot of the nitrogen, someday, I don't know, somewhere in the back of the hill someplace, shut your nitrogen applicator off for about 100 feet and see what happens. You won't get 0 yield. You'll get some yield. Where did it come from? Well, it came from the soil. And in some years, that 0 yield might look really good. I've had check plots with really low check nitrogen to begin a season, and in that perfect year of 2016, gosh, I had 180 bushel corn from check plots and 70 bushel wheat from check plots. Still a response to N, but the soil was just really churning out. So in a low yielding environment, let's just talk about dry weather, because you're most familiar with that most lately. So what happens with dry weather? Do you get much mineralization? Are the microbes really working a lot? They're not working at all. And so you don't get any nitrogen from mineralization. And roots, everybody thinks that roots grow to water, but they don't grow to water unless there's water in between. So they have to grow through moisture to get to moisture. They don't have some 900 number ESP person to talk to saying there's water down there. If there's a dry layer, the roots stop. And so in a year like this last year, you have very shallow root systems, and so you have a much smaller volume of soil for that plant to explore. And then the main way that nitrogen moves to a plant root is through a process we call mass flow, where the nitrate is dissolved in the water, and then the plant is taking up water and making, what, for lack of a better term right now, a vacuum. And so the water moves toward the plant roots, carrying the nitrate with it, and that transport is called mass flow. So in a dry year, is there any mass to flow? No, there's no mass to flow. And so it takes far more nitrogen per bushel to make the crop than it does in a normal year. And then in a perfect year, and I think you had a pretty good year in 2016 for the most part, perfect moisture, not too much, not too little, nice weather from the beginning to the end, and mineralization off the chart. The plants are happy, the microbes are is ultra happy, and so lots and lots of nitrogen being released from the organic matter and the residue. The roots are growing down to their full genetic potential because there's no dry soil, there's no really wet soil to grow through, it's just nice soil. And then there's enough mass to flow. So it took far less nitrogen per bushel to make that crop than it would in a normal year. So those are the bookends, and then there's everything in between. And so the whole gist of that is it really doesn't matter what the yield's gonna be. The same rate of nitrogen it's gonna take to get the most profit in a poor year is about the same rate of nitrogen it's gonna take to do it in a really good year. So forget don't even say, my yield goal is 60 bushel. I don't care. And you shouldn't care either. You should just go with the calculator and get on with life. All right. So I already mentioned this. So now I'll also mention this. So we have the phone apps and we have the web-based calculators. And over the next few months or so, it's going to these things are going to be revised, not because the formulas within them are incorrect, but just because we don't have the high-end prices and we don't have some of the high crop prices as well. But, like I said before, you can still use these, just divide everything by 2 and everything's going to be fine. Okay? So what about the other nutrients? We have a potassium calculator. It's designed for corn, but certainly work for wheat too. And it also has an economic component in there, so I'd invite you to take a look at that. Wheat doesn't need near as much potassium as what corn does, but you can still get some idea. You're not going to really need to worry about it until you get out into the Arvilla sands, where you can't build your soil tests up because it's just so sandy. You can put a ton of potash on one year and it's still going to be the same soil test the next year because the potash is going to be about 6 feet underneath with soil and the plant will never get to it. It leaches. You don't think about potassium leaching, but in the really sandy soils, low organic matter, like those Arvillas that are west of town here, it's not going to build, so forget it. But you have to put potash on, every year. And then the profitability from putting on phosphate also depends on the crop price and also depends on the phosphate price, but we don't have a phosphate calculator. But I want to introduce you to the only one that's in existence in the world. This comes from a very obscure little workshop conference out of Mandan about 25 years ago, 30 years ago. Ardell Halverson was a USDA ARS scientist. He worked in Sidney, Montana, and he worked in Fort Collins, Colorado, and then he came back to Mandan to manage the lab, research lab in Mandan for ARS. And somewhere between that Sidney and Mandan time, he put together this, because he did a lot of soil fertility work with Al Black and Orman Bauer back in the day. And so what that chart is the critical value where it'd be profitable to put on phosphate for wheat if the P price, the P205 price was 30 cents a pound, 60 cents, I think it's 60, and about $1 a pound. And so We're not quite $1 a pound, but we're pretty darn close. And what this is saying is that at those lower phosphate prices, which have traditionally kind of been our phosphate prices, then the critical value is what's in our tables. It's like 14, 15 ppm, something like that. And you get profit from putting on phosphate over and above what the starter is to that wheat when you do that. But as the phosphate price gets higher, then the profitability of 15 ppm just goes away. It's not profitable anymore. So it backs it down to about maybe 11 to 12 ppm. And then if you have prices that are pretty close to what they are today, then that critical value for P is down around, let's say, 8 ppm. So it's not the same. It's not the same. The profitability changes as the phosphate price goes up relative to the wheat price. So it's always a very good thing to put some phosphate on, some MAP on, something on for wheat, because it really needs it early in the season, regardless of what the soil test is. But putting those large amounts on because your soil test is really low in a really high phosphate price year is not profitable. So back it off. So here's a summary, and we'll open up for questions after that. So your residual soil nitrate values have been high this season. If soil analysis of each field has been done, if it hasn't been done, try to make it so. And then zone sampling is certainly the best, especially when you have possibility of high values out there, because your confidence is way high. My confidence is way higher if I see zone soil tests that are high compared to just a composite test. Use the nitrogen calculators to determine the profitable rate, divide it by 2 so that you can incorporate those higher end prices, and don't be afraid to back off the broadcast P rates this year. So there's my contact information, and many of you have been able to get a hold of me in the past, and that's certainly possible for this year too. So I bet I have time for questions.
You talked about the different types of soils under potassium, potassium, light or smectite or something. How do we know what kind of soils we have?
Yeah, so in the app, in the circulars, I actually went out to every county in North Dakota and east of the Missouri River, which is what you're interested in. I took it from 3 different major soil groups within every county. And so the map that I made for the state, which is insanely expensive, by the way, consisted of about 150 points. And so I have a map on areas that are greater than a ratio of 3.5 to 1 smectite to illite. And there's the white areas on the map are areas that are less than that. And so if you have more illite relative to smectite, then the critical value for corn is 150 ppm, and it's just fine. Actually, probably could be shaved lower than that, but I didn't want to just go nuts. So, but when you have higher than that, then the smectite, especially in the dry summer, it's really going to tie that phosphate up. The clays collapse, traps it inside, and I think it acts like if you have a wet area in a table, let's say, and you put a sponge on it, the water is drawn into it. I think that same thing happens with the clays, because they kind of act like that. But you can have a soil and you think you're okay with the soil test, and then you get some really dry weather in those high smectite soils, and you start to see potassium deficiency symptoms. So that's where, in a moist year, it really wouldn't make much difference, but this is North Dakota, and you never know what's going to happen, so you prepare for the worst and hope for the best. So 200 ppm for corn, so it's dependent on the clay type. If you're east of the river, Dan Kaiser is working on that. And if you're south of the border, Jason Clark's working on that in South Dakota. So this whole region is very interested in trying to figure out what's going on.